Hello, everyone. Welcome back. Today, we're going to be talking about using the four methods of solving quadratics, and mostly I'm going to be talking about when we can or should use each one, because not all of these will work for every single method, or sorry, every single quadratic equation that we could be given. So the first method is using square roots. So whenever we have the b value is 0, right? Whenever the coefficient of x is 0, that's a great time to use square roots because that's when we have something like, just to give an example, x squared minus 9 equals 0, right? If we have something like this, because there's no b value, right? Because there's no coefficient for x, or I could say that the coefficient for x is 0, we could just say that x squared is equal to 9 and pretty quickly and easily find that the solution is x is equal to plus or minus 3 in that situation. And so whenever we have anything of the form u squared equals d, or whenever we have something that could easily be written that way very quickly and easily, then just doing a direct solve using square roots is probably the fastest, easiest method. However, this only works when b is equal to 0, and there's many, many times when that's not the case. The second way to solve is to solve by factoring. Now, this can be a really good method if we can immediately see how to factor it very quickly and easily. We can factor using inspection, grouping, or difference of squares. So if we look at a quadratic and we can tell right away, oh, that's a difference of squares, then it's probably faster to just use the difference of square method to factor it and then solve it than to use any other method. Or same with by inspection. If we can quickly and easily figure out how to factor it by inspection, then go for it. And then same with grouping. If we can quickly and easily figure out how to factor by grouping, then we should do that. The downside to factoring is that some quadratics cannot be factored. And so that's kind of why factoring is not my personal favorite method for solving quadratics, because if that's the only method that you know of and you're faced with a quadratic that doesn't have a solution, or sorry, that doesn't have a way to factor it, either because it doesn't have a real solution or because the real solution is, something very complex, or I shouldn't say complex, that's the wrong word, but is something irrational, right? Like square root of 2 or square root of 105, or, something like that, that we're not actually going to be able to figure out quickly and easily by inspection. A direct solve is going to be a stronger method of figuring something like that out. And so factoring does not always work, unfortunately, either because, we're people and not computers and aren't going to know all the irrational numbers and what, how those can multiply and divide in certain ways. And also because sometimes there just isn't a real solution at all. So there's factoring. So long story short, if we can quickly and easily see how to factor it, fantastic. That's probably faster than any other method then. But if we can't, or even especially if we've been trying for a long time and can't figure it out, it could be because that's just not a way that we're able to solve it, or there could just be no real solution at all. The next method is completing the square. So it's easiest when a is equal to 1 and when b is even. The reason that's the case is because when a is equal to 1, we can actually skip the first step of completing the square, and we can avoid having to common factor out whatever the value for a is, if a is 1 anyway. And if b is even, when we take the b over 2 squared value, we end up with something that's just a regular integer, right? Just a regular positive integer, rather than ending up with a fraction or something like that. Now, that said, you can still complete the square when a is not 1, and you can still complete the square when b is not even. Absolutely, you can. However, it just won't be as convenient of a method, right? And in general, the completing the square method, I would say the biggest advantage is that it works every single time for any quadratic you could be given. You technically could use the difference of squares method, and so that's fantastic. That's a really good thing about it. However, I would say that in a lot of cases, it can take longer to do than the quadratic formula, because after we've completed the square, we still have to do a few extra steps to solve. We still have to isolate the x value and do a few extra steps. And so my personal favorite is the quadratic formula, but completing the square is probably the second best method in my opinion, because it does work for any quadratic we could be given, whereas method 1 and 2 do not work in all cases. That brings us to number 4, which is the quadratic formula, and this works in any situation. The only time I'd recommend not to use the quadratic formula is if you're on a test and you're specifically asked to use a different method, then of course use the method you're asked. However, if it's a situation where the teacher does not care which method you use, feel free to use this all the time if you'd like, and it will work, right? As long as we have ax squared plus bx plus c, right? As long as we can easily get the quadratic into this form, then we just plug in a, b, and c into the quadratic formula and solve, and we can get it. And so that way, whether there are real solutions or only complex solutions, or whether, no matter what the case is, we're going to always be able to solve it. And that is why the quadratic formula is such a strong method, because it's a very nice direct solve where all we need to do is generally just plug in some values, simplify, and we're done, which is pretty good. But anyway, feel free to let me know if you have any questions, and we'll see you for the next one.